These look like my little 9-volt batteries, or my little AA's.
Yeah, these actually run on 4 volts, but they're actually very similar concept. The battery pack also serves as a buffer in case it's cloudy. We can still run the car because we've got the sun's energy stored in these batteries.
So is this a wireless remote?
No, there's a steering column.
Oh, I knew that.
And then directly from the batteries, we run our motor, which I have right here. It's basically a magnet and a magnet that we can control. So by changing this magnet, we can get this to spin, and our wheel that drives attaches right here.
So then what are these pieces right here?
So some of the manufacturing techniques we use make the car very lightweight and strong.
Okay, what do you want me to do?
You're fine. We've got it up here. So instead of using metals for things like the body, the outside of the car, we use composite materials. And what that is, it just means that there's different types of materials that come together to form a very strong piece.
Now, this is really lightweight.
Right, and that's the whole point of it, because if the vehicle weighs less, then it's more energy efficient.
Oh, okay, that's really clever. I mean, that seems to be at the heart of what we're doing with this. Is this stuff strong?
Yeah, it's really strong.
Yeah?
Try to break it.
Try and break this? I mean, oh my goodness. That's not happening.
And then right here you can see we've got our the driver controls, which we mount onto part of the top shell. So when you're driving, you're going to see all those controls right there.
It looks like a GPS system. So James, you're a mechanical engineer. What exactly does that mean?
In general, it means that you deal with things that move. It's one of the more general types of engineers, and you can go into lots of different specialties in it. Yeah, but right now, it also deals with a lot of sometimes the machine stuff too.
So what are we doing here? What's this this big cube of aluminum we got going on here?
I'm right now cutting a notch into this to put the shock in, for the shock mount.
Oh, nice. The shock mount, that's for the solar car we saw earlier. So
Yeah.
this is going to make sure that we get a smooth ride every time.
Yeah.
Very cool,
This is
very
more
cool.
just to hold that little thing
Nice.
so it doesn't slip.
All right, so what are you doing now?
I'm putting a little oil on there to stop it from overheating and melting, and it lubricates the whole cutting part of the system.
Very nice, very nice. So then once you go ahead and put this on, what other role do you play as mechanical engineer with the solar team?
I mean, a lot of doing this stuff, even before you machine it, you have to use CAD drawings, computer-aided design, to actually draw how you're going to make it and how everything's going to fit together. Since you need to make tons of little parts and have them all fit together perfectly to make the whole thing actually roll and not fall apart.
Very cool. Now, when I was a kid growing up, I'm used to putting together model cars, so to do that in reality with an actual car must be pretty cool, huh?
Uh-huh. And there's a lot of work, too. What these are the suspension components. What you do is, this is called a kingpin. You have the wheel attached onto here. Then you have these A-arms attached down to both of these places, attached to the frame. And then you have the shock that's diagonal.
Okay. These are some of the suspension pieces you were talking about?
Yeah.
Not the suspension piece, but the spring here.
Yeah, that's the shock.
Shock, okay. These are like the pieces we would find in any normal car.
It's similar design, but it's much more lighter weight.
Right.
Like the shock is meant for a bicycle.
So now is there like a windscreen on that vent so that no bugs crawl in?
We haven't put one in yet.
Jesse, would you describe engineers as dorks after all of this?
Not at all. I gotta say, engineers are pretty cool.
So how do you feel about the energy game now?
Well, it's really kind of cool, you know. I mean, those 2 laws you gave us are the rules to the game, but those engineers are innovative in working with them.
Yeah, they're really clever. They get some energy from some pretty neat sources.
Yeah, I noticed something else. Every place that we've gone to, everyone is working in large teams, and everyone adds a little bit to the overall problem.
Yeah, do you think your problem could use that?
Seeing as how I'm not an expert in any of this, yeah, I'm gonna need a lot of help. But it's great that there are resources for things like this.
So what do you want to do now?
I think I want to go back and talk to one of those teams.
Great, have a good time. Maybe I'll see your work in the gym one day.
Hey guys, how's the robot coming along?
Oh, it's doing great.
Hey, my friend thinks that engineers are a little dorky. Clearly they're not. You think you can help me change his mind?
You bet. So hey, how'd you think of with the scientist? Did you get your question answered?
No, I didn't, but I learned a lot.
That's awesome. Good for you.
Well, hey, I was thinking about working on it a little bit. I could use some help. What do you say?
Seriously? Why would I help you on something so dorky?
Well, because it could be a really cool thing to do.
How?
That's how.
What was that?
That was engineering. Thanks, guys. Hey, if these high schoolers can build a robot capable of launching dodgeballs, I think the least we can do is try to solve the problem.
Will they be robots?
They'll be engineers.
With robots?
You have a one-track mind.
Eyes on the prize, man.
At the end of every fall, many schools have science fairs, which feature engineering categories. This is a great place for students to get involved in some basic technical work and work with their parents and teachers and mentors. If your school is interested in robotics, check out the First Robotics website. It's an excellent resource. Remember, engineers solve problems through diligence and teamwork, which means everyone can get involved. Every year, students need help with their science fair projects, and schools need help with mentors and judges. If you want to get involved in Chicago, go to the Science Fair website. Thank you for watching. And if you like this episode, make sure you thank an engineer.